Math 3, Unit 5, Section F. Today we're talking about applied problems with rational equations. So basically, we're dealing with the same type of equations that we had yesterday. It's just that they are now going to be in a word problem where we write the word problem and then we solve them. Okay? The nice thing is that I've only given you guys 4 problems for homework. Okay? Okay, I'll give you more. No. All right.
Love you, Miss Elto.
You're welcome. Okay. All right. So one thing I want you to remember is that when you're writing equations, you need to make sure you are writing a balanced equation. The reason why I say that is as we read through some of these, you'll kind of notice whenever you're doing a balanced equation, you want to do something to make it so that it's equal on both sides. So sometimes you have to add or subtract a number in order to make that happen. Okay, so here's our problem. I think that's Kayana. Can wash all the windows of a retail store in 6 hours. So we have one person and she washes the windows in 6 hours. And then it says that Maxwell can wash all of the windows in the same retail store in 9 hours. Okay, so we have 2 people doing the same job, but it takes them different amounts of times. Okay, then it says write an equation that can be used to find the time t in hours it would take Kayana and Maxwell to wash all the windows of the retail store together. Okay, so even if you think about this, most of you probably wouldn't like do this for fun, but maybe even like folding laundry at your house. You know, maybe it takes you 2 hours and it takes your mom an hour. So you guys could figure out if you guys did it together how long it would take. This is the type of problems that we're figuring out. Okay. So normally, and as you look here, there's one job. This is how I think about it. There is one job you're completing. Okay? So I always write it like this. One job, and it takes Kayana 6 hours to complete it. Okay? Plus, there's one job, and it takes Maxwell how many hours to complete it? 9 hours. And then your together time is always on the opposite side. And so one job, and we're going to label that as T for how much time it would take them to do that together. Okay, go ahead, write an X. It doesn't matter. Yeah. Okay, we'll change it to X. Okay. All right, so just like our other problems, we want to find our LCD of the problem because we want to eliminate all the fractions. And we also want to figure out, well, what are the extraneous solutions in case that ends up becoming a solution to the problem. Okay, so what would be the LCD, do you think, on this problem? 18x. Good. 18x. And my only extraneous solution would be what?
0.
Good. So x cannot equal 0, which that would completely make sense because there's no way it's going to take them no time to complete something, right? Okay, so the second part is now we're going to solve this equation. So I'm going to go ahead and rewrite it here again. So we have 1 over 6 plus 1 over 9 equals 1 over x. So we are going to do what? We're going to multiply each fraction by 18x, and this is just like what we did yesterday. Okay, and so the whole purpose is that we're going to eliminate the fractions, right? Okay, so 6 goes into 18 how many times? 3 times. So I have 3 times x times 1, which is just 3x. Okay. Next one, 9 goes into 18 2 times. So we have 2 times x times 1, which is 2x. Equals, here the x's cancel out, and I just have 18. Right? Because the x is canceled. Okay, so then 3x plus 2x makes 5x. 5x equals 18. And what would I do to finish solving this one? Good, divide by 5 to both sides. Now we're talking about time. Would we ever say time as 18 over 5 hours?
1857 hours?
Yeah. So what should I do? We can start by changing it to a decimal, but we're going to have to think about this too. In fact, well, so let's go 5 into 18, and 5 goes into 18 how many times? 3 times. 15, subtract 3 left over. And if you change this to a decimal and we put a 0 down, like you just said, you got 3.6. Do we normally even say 3.6 hours though? Mm-mm. We usually say like 3 hours and so many minutes.
36.
So how would we figure out how much 0.6 is?
It's a little over half.
It is a little over half. You are right.
Since it's a decimal. Well, because there's 60 minutes in an hour, and then
Good.
you divide it by 10 and multiply it by 6, you get 36 minutes.
Very good. In my head, what I do is that I know that minutes are 60 minutes, just like you said. If you take your decimal 0.6, or if you just take the decimal, and then I multiply that also by 0.6, I get 0.36, and that's how much it is. It's 36 minutes. So if you multiply whatever your leftover decimal is by 0.6, or if you just take that number and multiply it, you get it. So this means it is 3 hours and 36 minutes.
So you just take the leftover decimal and multiply it by itself?
No,
0.6.
0.6 because of
Oh,
60
okay,
minutes.
okay.
Yeah, 60 minutes in 1 hour, right.
Seven.
Okay, so far so good? Okay, so individuals' times go on one side. And basically what this is saying is that if you were to take each of them and they did the job together, so each of the individuals working together, it will make this answer. Okay, so we are able to make a balanced equation because one of them is them working together and we're adding the other one together. Okay, so B. A group of friends decide to evenly divide the cost of watching a premier boxing match on pay-per-view TV, which costs $72. Did I even say that? I don't even know. Okay, initially there are X friends, but then 3 friends that are not very nice decide not to watch the boxing match and spend their money to see Star Wars Episode 23, The Never-Ending Force, at the movie theater instead.
Why would you
We're
want to
getting
go
at
see
least-
Star Wars in
Exactly.
the first
I don't know
place?
why it's so specific, but I think it's funny. And I also think that that is super rude of friends that they say they're going to do something and then they back out.
Confirmed.
Okay.
We're getting like a lot more Star Wars movies.
All right. So
16.
this causes the people that are watching the boxing match to have to pay more money. In fact, specifically $2 more. Okay. So we want to figure out, well, how many people are actually there? Sounds fun, huh? Okay. So originally it is how much money?
$72.
And originally there are how many friends?
X friends.
Very good. So I'm going to go back through here. Originally we $72 divided by X friends. Are we all okay with that? Okay. Because if we take 72 divided by the number of people, it gives us how much money they owe. But that doesn't end up happening, does it? Okay, so one side of the equation is that, okay, what like the original thing is. The other side of the equation is what ends up happening, but we have to make it balanced. Okay, so what ends up happening? What do we end up dividing by? Do we add people to X? Because it says how many people end up not coming?
Maybe X minus 3.
Very good. Because 3 friends decide not to watch the movie. So that means that we end up taking our 72, and this was a bigger number, right? And we're going to take 3 away from it. So we're going to divide by X minus 3 because there's actually 3 less people. Which means it ends up costing more money, correct? So right now, this is not a balanced equation. We have to do something to this side in order to make it balanced to what it was originally. So it has to do with the $2, okay, because they end up spending $2 more, okay?
Plus 2x.
Close. It's not going to be adding 2, and it's not going to be X, because we're not adding people, right? We're adding money.
Just plus 2.
Close. It's actually going to be subtracting 2. Okay, so real quick in your groups, I want you to talk about why we are subtracting 2 on this side versus adding 2.
Each person has to
Yeah, so
out.
yeah.
So try talking to each other. That means like words come out, and you. All right, did anybody make sense that they could maybe share with us? Somebody in your group say it and you're like, oh, okay.
Oh, no, he's
I
not.
nominate the software.
Okay, Carson,
They
thanks.
lost money, they had to pay more, so they lost money, so subtracted.
Basically, yes. I'm going to say it another way, or does somebody else have something else they could say? So if you think about it, when you take 3 away, so like let's just say this number was originally, I'm trying to think of a number that's not the number. Let's just say it's 5, okay? If you take 72 divided by 5, it doesn't work out evenly, so I'm just going to plug it in here. 72 divided by 5, that's 14.4 here, right? If we go 5 minus 3, because 3 less people do it, and I go 72 divided by 2, I get 36. So this ends up being like a bigger number, right? So in order to balance it out so that they're paying the same amount, you have to subtract 2 on this side.
That makes sense.
Does that, so we're trying to balance it. So if you think about it, this will end up being a bigger number, so to make it equal to this, we could subtract 2. Now, in the same regards, could I have done something else different? What could I else, how else could I have set this equation up? You could actually add 2 to this side if you wanted to, and that would also balance it out. Okay? So if you had 72 divided by x and it had the plus 2 on that side, it would also work. Okay. Are we okay with this or no? No? Yes?
Okay.
Okay. So what would be my next step then on this one?
LCD.
We're going to do our LCD. So that 2 is fine there. So we are going to find our LCD. And so on this problem, what will my LCD be? X times x minus 3, good. And then my extraneous solutions will end up being what?
0 and positive 3.
Good. Okay, any questions on that? Okay, so I'm going to rewrite this problem down here. 72 over x equals 72 over x minus 3, and then subtract 2. And so I'm going to take my LCD and multiply it to every single term, right? So we have x times x minus 3 to each term. Okay, on the first term, the x's cancel. And I'm just going to write this for a minute as 72 times x minus 3, and I'll distribute in a minute. Equals, here the x minus 3's cancel, and I'm left with
X.
72x, right? Gabby getting this?
Yeah.
And then my last one, I have minus 2x times x minus 3. So now I'm going to go through and distribute. So 72 times x makes,
72x,
and then 72 times negative 3,
negative 260.
very good, equals 72x. And then we have minus 2x times x, which is
2x squared.
negative 2x squared. And then negative 2x times negative 3 is,
Positive 6x.
Colton, can you write some of this down? Okay. There's one thing I notice. Do you guys notice anything about this equation right now?
72
not
x's can
missing
cancel out.
The 72x's can cancel out. Do you guys see how there's a 72x on both sides? So just to make my life easier, I'm going to cancel those out. Okay, what else? What do you think we're going to have to do?
Get a 0 on one side.
Yeah, and we're going to
Add 2.
factor, right? Okay, now which way, it doesn't matter which way you move things. It's just usually easiest if your x squared is positive. If your x squared isn't positive, you have to factor out a negative in order to factor. Okay? So I'm just going to move everything to the left to just make sure my x squared is positive. So I'm going to add 2x squared and subtract 6x. So that leaves me with 2x squared minus 6x minus 216 equals 0. Okay, and you'll find on most of these problems that there is a GCF, and hopefully you see that 2 divides evenly into each of those numbers. Okay, so you're not going to multiply over and do that. That's only if you can't take out a GCF. Okay, so I can take out a GCF, so I factor out a 2, and I get x squared minus 3x minus 108 equals 0. Okay, so that means we're looking for a number that multiplies to be negative 108 and adds to be negative 3. Okay, if you are ever not sure, you're like, no idea. What I do is I just start making a list of numbers and I go in order. Okay?
Three goes in the
Yes, in fact, no.
So like I have 1 and 108. Obviously that's not going to work. We have 2 and 54. If you divide in 3, it's 3 and 36. 4 and 27. 5 doesn't work. 6 and 18 doesn't work. 7 doesn't work. 8 doesn't work. And then we get 9 and 12. But do you see if I go through every number and try every single number, I get all the factors, all the numbers that multiply to be 108, and hopefully through these, I can find the number that works. And as you can see right here, those can make 3, right? So which one will need to be negative? 12, right? So that means we have x plus 9 and x minus 12 equals 0. When you set those equal to 0, so you're setting each of the factors equal to 0. Remember, even 2 equals 0 doesn't make any sense. That's not true. That's out. Okay, and then we would get x equals negative 9 and a positive 12. Now, can we have negative 9 people? No. So that's out. So my answer is x is 12 people to be my initial amount of people. And what I like to do is plug it back in to see if it actually makes sense in my original equation. So if I plug this back in here to my original equation, sorry, what is 72 divided by 12?
6.
6. Okay, do we all agree with that? Okay. So that means 6 people, or $6 is what they would have originally paid, right? Okay. Then if we go here, what is 12 minus 3? 9. What is 72 divided by 9? 8. And then minus 2. Does that make a balanced equation? Yeah, right? Because that ends up making 6 equals 6. Okay, and they paid $2 less if they had. Exactly, thank you. Okay, so I also feel like this shows like how important it is to plug it back in to just make sure it makes sense. Okay? All right, we're gonna move on and do a couple more. Do we have questions though before I move on? Okay, flipping over to the back. This goes back to more like example A. Okay, so it says if 2 inlet pipes can fill a pool in 1 hour and 30 minutes, and 1 pipe can fill the pool in 2 hours and 30 minutes, how long would the other pipe take to fill the pool on its own? Okay, I want to see if you guys can set this problem up. So there are 2 pipes working together, right? Or there's 2 pipes total. So remember you're going to have your individual pipes on one side as a fraction, and then when they work together on the other side. Also think about how you would write 2 hours and 30 minutes and 1 hour and 30 minutes as a decimal. Okay, because is it going to be 1.3?
No.
No. What will it be?
1.5.
1.5. Okay, so all I want you to do is just set it up. I don't want you to solve it. Okay, so our together time always goes on the right side. So what fraction are we going to write on this right side? Because here it's saying if 2 inlet pipes can fill a pool in 1 hour and 30 minutes. So that's together, they're working 1 hour and 30 minutes. You have one job that they're completing, and it takes them what? 1.5 hours. Okay. Is that okay?
I read this in a different way.
Oh, okay. So this is the two ones working together, 1 hour and 30 minutes. Okay, it says one pipe can fill the pool in 2 hours. So one job and that pipe fills it, 2 hours and 30 minutes. So that one job, 2.5 hours. And then it says, how long would the other pipe take to fill the pool on its own? So we don't know the other individual time. So that one, again, one job and then X time. And that's what we're trying to figure out. Yes, Serena?
Wait, so for the end, would it not be 2 pipes? Since it's just for the one?
No, so you have like your individual times together on the left side and then the together time on the other. So just like when we go back, if we go back to this example,
That's, I don't think that's what she's asking.
is that not what she's
I
asking?
think what she's asking is since there's 2 pipes, why wouldn't it be 2 on the top?
Good question, because it's still one job. So they're both filling the same pool. So one time they're filling the same pool together and then one, they're doing them individually. Okay? All right, so on the tops, usually it will always be like one job being completed in some amount of time. Okay, now decimals and fractions don't really go together in the same problem. So how could I end up getting rid of these decimals?
Multiplying them.
By what?
By the denominator.
Or by 10.
Or
Yeah. Multiplying by 10, right? So basically, if I want to move this decimal place one time, I have to move this one also one time. So basically what I'm doing is I'm multiplying by 10 to both the top and the bottom there. Is that okay with everybody? So I'm also going to do that on this one. So I'm going to move this decimal place once, so I'm going to end up moving this one once. If you like wanted to double check that you really didn't change the problem, if you take 1 divided by 2.5, just going to show you. Okay, 1 divided by 2.5 equals 0.4. And then if I go 10 divided by 25, it also equals 0.4. So do you see how we are not really changing anything? Okay, since I'm multiplying both the top and bottom by 10. Okay, what would be my LCD on this problem?
25.
75x.
15.
So 25 is 5 and 5, right? 15 is 5 and 3. So we need at least 2 5s and 1 3. So 75x is correct. Now, could you multiply 25 times 15 together and use that number? Yes. You'll just have to reduce more at the end. So do you guys understand how I thought about that in my head? Do I need to write it down? Okay. Okay, so 25, if I do a factor tree, 25 is 5 and 5, 15 is 5 and 3. So see how they both share 5s?
Yeah.
But this one has 2 5s. So I need at least 2 5s in my LCD, but this 5 is taken care of with these 2 basically. And then I still need a 3. And so it's just a combination of them, just like how we did with the other one. So we get 75x, and then my extraneous solutions would just be what? X cannot equal 0. Okay. So we're going to eliminate our fractions now. And so what am I going to multiply? I'm going to go through and multiply the LCD, 75x, every single term. Okay, on the first one, 25 cancels out, and I'm left with
50. No, I'm stupid.
3. And then 3 times x times 10 makes,
30.
yeah, good, 30x. Okay, here the x's cancel out. And 75 times 1 is just 75 equals, and this last one, 15 goes into 75 5 times. And 5 times x times 10 is, so then we subtract 30x to both sides. 75 equals 20x, we divide by 20 to both sides. And does that make any sense, writing an answer as 75 over 20 hours? 75 over 20 hours? No. Okay, so we could reduce the fraction by 5, or we could just divide 20 into 75. 20 goes into 75 how many times? 3 times, which is 60. You have 15 left over. So I have, we can add a decimal and a 0 if you guys want to. And 20 goes into 150 7 times, which is 140. 10 left over, add another 0, and that is, so 0.75 of an hour. Do you guys know what 0.75 of an hour is?
We multiply by 6.
So we can take 0.75 and multiply it by 0.6.
Why do we multiply by 0.6? I know what we did the other one, but why do we multiply this one by
It's
0.6?
46.
How many minutes are in an hour?
60.
That's why we're multiplying by 0.6. It has to do with the 60 minutes.
Oh,
Okay?
6.25.
No.
Oh, wait, no.
So if you take 0.75 times 0.6, you end up getting 0.45, which means 45 minutes. So we have 3 hours and 45
Oh, you
minutes.
only did decimal.
Yeah,
Oh, okay.
because the 3 part is your hours.
Yeah, one pipe is real fast, one pipe is real slow.
Okay, last one. Okay, I want to see if you guys can set it up.
Second, third.
So how many fractions are we going to have? 3. Do we know what number goes on top of all of them?
So it's just going to be 1 every time unless they're trying to accomplish.
On these kind of problems, right.
Okay.
Unless if you had 3 people working together, then you'd end up with 4 fractions because you'd have the 3 individuals on one side and then the working together on the other side. Okay, so,
All might be 1 on the top.
I'm so glad the camera, or the video got that.
okay. So what's going to go on the bottom of my fractions?
5.
Okay, so Huck Finn can paint the fence in 5 hours. So that's an individual time, so it's going on the left side. So 1 job, 5 hours. Tom Sawyer can help him paint the fence. They can do it in 3 hours. Where is that 3 going to go? Very good. And they want to know how long will it take Tom by himself. And so underneath there, we're just going to put in X. Okay, so now can you guys solve this? I think you can.
Shut up.
If you get the answer, raise your hand and I'll come check it. Perfect. 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 You guys are so smart. Good.
What?
Yeah. Perfect.
Yes.
Okay, it looks like almost everybody got it. Or everybody got it, actually, I think. So I'm going to work through this a little more quickly. So I'm multiplying every single term by 15x. So here 5 goes into 15 3 times. 3 times x times 1 is 3x. Here, x cancels. I have 15 times 1, which is 15. Here, 3 goes into 15 5 times x times 1 is 5x. In order to solve the equation, we subtract 3x to both sides. 15 equals 2x. We divide by 2, and I get x equals, when I divide 2 into 15, it goes in 7 times, which is 14. 1 left over, add a decimal and a 0. 2 goes into 10 5 times. And we are so smart that we know that means 7 hours and 30 minutes, because 0.5 is half an hour. We know half an hour is 30 minutes. So we didn't even have to do anything else. But if we multiplied 0.5 times 0.6, it makes 0.30, which is 30 minutes. Questions?